So this time we are going to take a look at series and sigma notation. Once again, please complete the notes as you are watching this notes video. There will be a problem solving set based on this information, and you can use these notes to help you with that problem solving set. So some new definitions. Series is going to be the indicated sum of the terms in a sequence. So a series is a sum of a sequence. Arithmetic series then is a series whose related sequence is arithmetic, and geometric series is going to be a series whose related sequence is geometric. We are going to talk about the Greek letter sigma, and in this case, sigma is used to show summation notation when we are taking a look at series. So we use the sigma symbol to write a series in an abbreviated form. So let's take a look at some examples. So we want to write the series from j equals 1 to 3 of negative 1 to the j times 3j plus 1 in expanded form. So these numbers can change. Your problem does not always have to start with 1. And this is going to tell me where I want my problem to end. So I'm going to do the first, second, and third term for this series. But again, if this number at the bottom was different, for example, say it was a 0, then we would be starting with plugging in 0. If this bottom number was a 5, we would be starting with 5, the fifth term, and then going to whichever term they are asking me for. When it's asking you for it in expanded form, it's asking you to write an addition problem, but you don't need to actually find the answer to that addition problem. So what I'm going to do here is start with j equals 1. So I'm going to do negative 1 to the first times 3 times 1 plus 1. Then I'm going to do my second one. So I'm going to do negative 1 to the second, and then 3 times 2 plus 1. And then I will do the third term. So I'm going to do negative 1 to the third times 3 plus 1. Now I'm going to simplify those terms, but again, I'm not going to actually add them together. So negative 1 to the first is negative 1. 3 times 1 is 3, plus 1 is going to give me 4. So this is going to be negative 4 plus negative 1 squared is 1. 3 times 2 is 6, plus 1 is 7. So then 7 times 1 would give me 7. Plus negative 1 to the third is negative 1. 3 times 3 is 9, plus 1 is 10. Negative 1 times 10 is going to give me negative 10. And this would actually be my final answer, negative 4 plus 7 plus negative 10. Okay, now we're going to go the other way. So use sigma notation to write each series. Well, in order to do that, at first I'm going to have to come up with a formula. Keep in mind that these could be arithmetic, they could be geometric, or they might be neither, but still have some sort of pattern that I could write with that sigma notation. Also notice that these two examples have a beginning and an end, whereas my example in number 3 has a beginning but no end. So we'll take a look and see what that looks like. So here I am noticing that if I add 3, that seems to work, so that would make this arithmetic. So then I'm going back to my lesson 2 notes that we had done, and t sub n would be equal to t sub 1 plus n minus 1 times d. So t sub n would be equal to my first term, which is 4, plus n minus 1 times the difference, which is 3. So t sub n would be equal to 4 plus 3n minus 3. So t sub n is equal to 3n plus 1. So that's then the formula that I'm going to put into my summation notation. So my summation notation would so far look like summation from n equals 1 to something. We don't know what that something is yet, but we do know that the formula is going to be 3n plus 1. Now let's figure out how far this needs to go. So to do that, we're going to plug 61 in for t sub n. So 61 is equal to 3n plus 1. So 3n is equal to 60, which means n is equal to 20. So my top number would be 20. So my sigma notation, my summation notation would be the summation from n equals 1 to 20 of 3n plus 1. For the second one, I am noticing that 3 times 2 will get me 6, and 6 times 2 will get me 12, so that makes this a geometric. So that formula from lesson 3 is t sub n is equal to t sub 1 times r to the n minus 1 power. So t sub n would be equal to t sub 1, which is 3, times the common ratio, which is 2, to the n minus 1 power. So again, so far in our summation notation, we would have summation from n equals 1 to something of 3 times 2 to the n minus 1 power. Now again, we need to figure out what that something is, so we're going to do 1,536 is equal to 3 times 2 to the n minus 1. We're going to divide both sides by 3 first, so that would give me 512 is equal to 2 to the n minus 1. 512 is going to be 2 to the 9th power is equal to 2 to the n minus 1. Drop the 2's, so 9 is equal to n minus 1, so n is equal to 10. So my top number would be 10. So this is the summation of n equals 1 to 10 of 3 times 2 to the n minus 1 power. And then for my last example, 2/3, 4/5, 6/7, 8/9. So there is not really anything I can add to 2/3 to get 4/5 that I can then add to get 6/7. Now also nothing I can really multiply 2/3 by to get 4/5 and then multiply it by that same value to get 6/7. So that means this is not arithmetic or geometric, but I do notice that there is a pattern. So if I number my terms, this is 1, 2, 3, 4, I notice that the top number is always twice the term number. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So that means that the numerator of the fraction is 2n. On the bottom, 3, 5, 7, 9, again, I do notice that the bottom itself is arithmetic. So that means that on the bottom, we could do t sub n is equal to the first term, which is 3, plus n minus 1 times the common difference, which is 2. So t sub n would be equal to 3 plus 2n minus 2, which means t sub n is equal to 2n plus 1. You might have also noticed that the denominator was 1 more than the numerator. So since the numerator is 2n, the denominator would be 2n plus 1. Then for the summation, so that's going to be from n equals 1. And then again, as I pointed out earlier, there is no end to our series. So that means that this is going to infinity. So we would have the summation from n equals 1 to infinity of 2n over 2n plus 1. So again, you will have a problem-solving set on this information, and then there will be a Schoology assessment for you to submit your answers to. Please see your teacher if you have any questions. Thank you.